One of the big promises of containers is that we can easily deploy our apps like we were a platform service, like Heroku or something. But we could do that on anyone's hardware, whether it's on our hardware or it's a cloud provider, whether it's virtual or physical. And with Docker, our apps can run the same, whether they're in Amazon, Azure, DigitalOcean, Linode, Rackspace, Google Cloud, or whatever. But without all those platform features, how do we easily deploy and maintain our dozens or hundreds or even thousands of containers across many servers or instances, or nodes or droplets or whatever? So that brings to bear some really new problems that weren't previously problems for small organizations. Now, we all know about Netflix and big organizations like that scale to thousands and thousands of nodes and tens of thousands of nodes, and they've got lots of engineers. But if you have just a couple of people on your team, or if you're just a solo developer, how do you take your containers and scale them and deal with their entire life cycle, from deploying them to starting them to restarting them to recreating them to deleting them and updating them and all that? So we start to ask questions around how exactly does Docker do that, or does it even do that at all? Some of the questions we ask ourselves are things like, how do we scale out? How do we scale up? How do we ensure that our containers restart if they fail? How do we replace those containers when we actually have an update for them, which is something called blue-green deploy nowadays, which means that you have zero downtime and you take servers out of the pool in order to bring new ones in, and you end up with always something available so that you're never really down when you update. Or how do we know if we've got dozens of nodes or even just 3 nodes, where we started those containers? Which node is our container on? How do we talk across those different nodes or servers with our networking inside the containers? And when it comes to security, how do we be sure that our containers are only running on the machines that we intended for them to run on? And now that we're moving things around and deploying them dynamically on the fly, how do we store the private information we need for our containers, like secrets or passwords? So this brings us to a major evolution in the scope of what Docker tries to solve. And when people talk to me and they think that Docker is just a container runtime, that's when I actually just mentioned Swarm Mode, which is a brand new feature in 2016 that brings together years of understanding the needs of containers and how to actually run them live in production. So at its core, Swarm is actually a server clustering solution that brings together different operating systems or hosts or nodes or whatever you want to call them into a single manageable unit that you can then orchestrate the lifecycle of your containers in. And just to be clear, we're not actually talking about Swarm, which I'm just going to call Swarm Classic, which was a add-on component to Docker before 1.12 came out. And it was really a container that would run inside of Docker that really just took your Docker run commands and repeated them out to multiple servers. It did solve a few problems, but it wasn't really at the scale that we needed to truly solve 80% of the cases for how you're going to run your containers. In the summer of 2016, at DockerCon 2016, actually, Docker announced SwarmKit, which was a set of libraries or a toolkit related around a whole bunch of new Swarm features, and then they stuck that right in the Docker server. All along in this course, you've actually had the features available to you in the CLI and on your server, and now we finally get to dive into them. In January of 2017, 1.13 came out, and of course, because Swarm Mode was new in 2016, they're going to continue to make it better in the years to come. So in January, they added additional features called stacks and secrets, as well as other bonuses we'll talk about later. And it's important to note that Swarm is not actually enabled out of the box. In fact, on your machine, you couldn't use these commands listed here right now. They would actually give you an error because Swarm has to be enabled. And that was one of the design goals, was that none of the Swarm code would affect the existing Docker daemon, and that all the tools and systems out there that were already relying on Docker, or maybe they had their own orchestration on top of Docker, would continue to function and not be interfered with by Swarm now being a part of Docker. So some really basic concepts before we start diving in is that these blue boxes you see up at the top are what we call manager nodes, and they actually have a database locally on them, known as the Raft database. It stores their configuration and gives them all the information they need to have to be the authority inside a Swarm. And so what we have here is 3 different managers that have all been added to the swarm, and they all keep a copy of that database and encrypt their traffic in order to ensure integrity and guarantee the trust that they're able to manage this swarm securely. And below in the green, we actually have worker nodes. So now you can see in the concept of swarm, we have now managers and workers. Each one of these would be a virtual machine or a physical host running some distribution of Linux or Windows Server. This is showing how they're actually all communicating over what we call the control plane, which is how orders get sent around the swarm for taking actions. And in a little bit more complicated view, we have this Raft consensus database I mentioned that is replicated again amongst all the nodes. They issue orders down to the workers. Now, the managers themselves can also be workers. And of course, you can demote and promote workers and managers into the 2 different roles. So when you think of a manager, typically think of a worker with permissions to control the swarm. And again, the only requirements for each one of these servers is that they're running the same Docker that you're already using now. With this concept of a swarm and these managers, we now have new concepts of what our containers look like. And so with the Docker run command, we could only really deploy one container. It would just create a container. It was always on whatever machine the Docker CLI was talking to. That's usually your local machine or maybe a server that you're logged into. But that Docker run command didn't have concepts around how to scale out or scale up. And so we needed new commands to deal with that. That's where the Docker service command comes from. And in a swarm, it replaces the Docker run command and allows us to add extra features to our container when we run it, such as replicas to tell us how many of those it wants to run. And those are known as tasks. A single service can have multiple tasks, and each one of those tasks will launch a container. So in this example, we've created a service using Docker service create to spin up an Nginx service using the Nginx image like we've done several times before. But we've told it that we'd like 3 replicas. And so it will use the manager nodes to decide where in the swarm to place those. By default, it tries to spread them out. So each node would get its own copy of the Nginx container up to the 3 replicas that we told it we needed. This is a quick and basic understanding of how the managers work and what they're doing in the background. And all these features are new. It's not simply just taking your command and running it on an API like we would experience with a Docker run command. There's actually a totally new Swarm API here that has a bunch of background services such as the scheduler and the dispatcher and the allocator and orchestrator that help make decisions around what the workers should be executing at any given moment. And so the workers are constantly reporting into the managers and asking for new work. The managers are constantly doling out new work and evaluating what you've told them to do against what they're actually doing. Then if there's any reconciliation to happen, they will make those changes, such as maybe you told it to spin up 3 more replica tasks in that service. And so the orchestrator will realize that and then issue orders down to the workers and so on. So with this swarm mode, we actually get a feature-packed set of capabilities out of the box that allow us to already use the existing Docker skills we have in order to deploy our containers to the internet in a reliable fashion and solve a lot of problems that we would have once we go production.